Good afternoon.
Afternoon.
My name is Addis Elliott. I'm a senior computer engineering student.
My name is Kadeem Jones. I'm also a senior electrical engineer.
I'm Christian Ford, senior electrical engineering student.
And this is our project entitled Wireless Audio Distribution System.
Okay. The motivation of our project is to develop a solution that would solve the problem of destruction ruckus in a sports bar. We will try to allow all patrons at a particular establishment the luxury of enjoying the entertainment of their choice in an atmosphere that makes it difficult, if not possible, to do so regularly. We also would like to develop and implement the design using wireless technology that will address the issues without completely changing the atmosphere in which patrons come to socialize and view varieties of entertainment.
Next slide. So just to give a full overview of what we're going to go over today, we're going to start off with a little bit of the background and problem analysis, which includes our need and objective statements, some of the requirement specifications that help guideline us as we go through our project, level 0 through level 2 block diagrams, some a UML diagram, test document for a test that we're supposed to do, work breakdown chart, the Gantt chart, cost summary table, and one of the external student competitions that we're supposed to be a part of. Next slide.
So continuing with the background and problem analysis, where the need for this arises is at social gatherings such as sports bars where there is multiple audio-video outputs and there is a confined area where ambient noise is an issue. And so often what you find is it's hard to listen in on one audio output because there's a lot of other noise going on, whether it be other conversations, just background noise, or another audio output being displayed. And that's the problem and the need and where that need is found at. Continuing with the problem, so the way in which we go about answering this need and solving this problem is by creating a wireless distribution center that allows for multiple, at least 2 audio sources to be broadcast wirelessly to multiple personal listening devices. We want to allow that so that way it kind of solves the problem, because if it's personal, then you won't have to worry about background noise, because then you have the option of hooking up to a headphone or a speaker that is very close by, which helps reduce and drown out all of the background noise. And so for this system that we are creating, we want it to allow that patron to select the channel for which it will want to receive the audio output from one of the multiple sources and be able to play it on his or her personal listening device. We want this to hold at least 10 users to be able to select from at least 2 audio sources. The requirements, the specifications. So to go into the requirements of this, based with the engineering requirement, macro requirements. So our macro requirements all derive from 4 marketing. Our engineering requirements all derive from 4 marketing requirements. The marketing requirements are: the system must be user-friendly. Number 2, the system must be interoperable with the existing market. The system must be manageable, and the system must produce quality audio. So now I'm going to run through each one of our engineering requirements and explain our justification, our thought process behind why we chose each one of them. So for our first engineering requirement, the application must allow for the user application to be. The system must allow for the user to understand its capabilities within 5 minutes. We thought this was a very important engineering requirement, and one that played on the marketing requirement of being user-friendly, because if you cannot understand the capabilities of a system that you are using within the first 5 minutes, especially a system of this something that's not as complicated, if it takes longer than 5 minutes to do it, then it is not user-friendly and not intuitive at all. Continuing with user-friendly, the system must have a setup time of less than 10 minutes. Once you reach that 10-minute threshold of setting up your personal listening device to an audio source, so if you're at a social gathering, your attention span is being drawn from multiple places, so your need for wanting to listen to that device may change, and so it may cause the system itself to lose value. Going to the second marketing requirement, which it must be interoperable with the existing market, we want our system to be compatible with at least 2 different wireless audio devices, wireless audio distribution systems. And by distribution systems, I mean to say Bluetooth or analog, and that's something that we are looking to have our options open right now as we continue to develop and figure out the best option for that. But we want it to be open to multiple things, so that way, no matter what your personal listening device is, you will be able to hook up with the wireless broadcast system, making it interoperable with the market today so you can use your own device. The last one is it must accept the output of a minimum of 4 stereo to mono. That really continues with the need for, that continues with the need to be interoperable with the existing market, because if I have a stereo output a stereo input for my listening device, or whether it is a mono input, I want to be able to have the option to use it. And so this allows for that. This requirement allows for that. The third marketing requirement is the system must be manageable. And by manageable, we're really referring to physically manageable. So the girth, the actual physical space this device, the system takes up. And so by that, we say that we want our whole system to be able to fit in a laptop bag with a rough dimensions of 16 by 16. Because once you get there, it becomes too cumbersome, and it's really a burden on the user and the person who's setting it up. The final one under the system must be manageable is the hardware must weigh less than 3 pounds. Excuse me. After that, it's a lot of things. Like if it's on a desk or if it's on your table at the pub or wherever the venue is, once it starts gaining in weight, it becomes more of a risk. And so we just want the system to not be a burden on whoever's using it. The final marketing requirement that we have derived engineering requirements for is producing quality audio. So we want the output to not experience distortion within a 15-foot radius. If you're receiving distortion outside of that radius, the system really loses value, and it's not really producing quality audio at that point. The final engineering requirement is the analog audio mixer must combine 2 distinct signals into one. We really want and be able to have them generated simultaneously. This mixing process is essential to the operation of the system. If the 2 signals cannot be mixed, then our system will fail to produce quality audio. And this is something that is also seen as a need when you come to the stereo and mono of the earlier engineering requirement.
Okay, about 7. So
Number 7, okay.
No, yeah, you say 7 devices in less than 10 minutes. The system must have a setup time for 7 devices. What's magical about 7?
7 was just a higher number on the 10. So our requirements initially, based on our need, was 10 devices.
Right.
And so we didn't want it to be half. We just chose we wanted to put our a challenge as a goal we want to meet as far as 7 devices, because just to.
All right, I got you. One thing I would say about the one for the 15 feet, must not experience distortion within 15 feet. So I would say put some parameter on that, something you can measure. So what about the distortion? It shouldn't be less than whatever. There's a certain amount of attenuation or noise or whatever, interference. Something that you can measure.
Okay.
All right. Signal to noise ratio probably would be a good measure. And we'll probably talk more about the last one, combining the signals. I know that applies to what we're doing today, but still, I probably want to word it differently.
Okay.
I can't think of exactly how right now. We'll talk about it.
Next slide.
All right.
Okay, here is a level 0 diagram of our wireless audio distribution system. The functionality of this system will allow for audio from at least 4 separate sources to be broadcasted wirelessly in a confined area simultaneously. The system should allow the user to select the audio channel of their choice to play through their particular listening device. It should also allow at least 10 people to listen to each audio stream simultaneously. So some of the inputs are, we have from 0 to 3 stereo audio, which are to be used as input stereo channels. We have 0 to 3 audio select, which is to be used as an audio input for the channel selectors. We also have, as outputs, we have indicators, which are LEDs, which it's gonna let you know which channel has been selected. We have controls, which are the controller signal that allow each output audio peripheral to choose which input source to receive media from. So this is just an overview of level 0.
So going a step deeper into our system, we kind of brought it to a level 1 block diagram, so where we kind of separate our system into different blocks and to how the actual system will function. So we have 3 separate blocks. Our audio selection unit is our first block, audio broadcasting unit is our second block, and our personal listening system is our third block. The personal listening system, as you may notice, has multiple different systems, so it's represented as one block that could be multiplied depending on how much personal listening systems are being in use at the time. Our audio selection unit, just to go a little bit into that, functionality is to allow the reception of multiple audio inputs and output those based on the input received from the audio selection line. So the audio selection unit allows you to select what sources are you going to choose to display your audio and send it wirelessly to the next block. Send it by stereo to the next block. The next block is the audio broadcasting unit. Within this unit, the function of this unit is to receive a wired input from stereo from the first block and then send it wirelessly to the personal listening system. So this unit has stereo audio inputs and wireless audio outputs. Now it sends it to the third block, which is the personal listening system. The personal listening system allows you to receive 2 wireless audio signals and output them as another audio signal to your personal listening device, whether it be some headphones or whether it be a wireless speaker. So just that personal listening system allows you to receive the audio from the audio broadcasting unit, and then it also allows you to select which source that you originally selected that you want to actually listen to. So this is just a level 1 block diagram that goes a little deeper into how the entire system interacts. Next slide. On level 2, we go a little step deeper to kind of give you an explanation on how the audio selection unit actually works. So then within the audio selection unit, those stereo audio inputs come in to the selection unit, and they go through a stereo mono mixer. So that's the first block of the level 2 audio selection unit, the stereo mono mixer. Within the stereo mono mixer, what we're doing is, one, we're replicating the stereo inputs that came in from the stereo audio inputs, and also mixing those 2 inputs to create a mono input. So those 4 stereo audio inputs now are going to produce 12 different 12 different mono outputs from the stereo mono mixer. So now it then goes to the next block, which is the channel mux system. Within the channel mux system, what our idea is to actually help select which lines or which audio sources get channeled to the next block, which is the audio broadcasting unit. So within the channel mux system, it's just a selection process that's going to be done with logic that allows us to select what actual sources get channeled to the next block. And then we have the third block within there is the LED array. And the LED array just allows us to give an indicator for what channels have been selected. So you kind of just see a LED based on whatever channel you selected. So it's tied directly to the selection lines, and it allows you to see what channels have been selected. Next slide. The UML diagram. So we're going to go over the UML diagram that kind of goes into our personal listening system a bit to give you guys an understanding of the end phase of the entire system. So within the personal listening system, we already know that it receives 2 wireless audio signals. So upon reception of 2 wireless audio signals, the personal listening system also has to receive a control line input, which allows the user to select which audio line they want to listen to. So once you select that audio. Once you select that audio, you go to the next phase, which is deciding which line you're actually listening to, whether it be a stereo line from channel A, a stereo line from channel B, or any of the 4 possible mono lines from channel A or channel B. And once you identify whether it's a stereo line or a mono line, then you go to the next phase, which is to transfer the audio to the personal listening device. So if it's a stereo input, let's say on channel A, it transfers channels A mono left signal and channel A mono right signal to both the left speaker and the right speaker of the personal listening device. Same goes for channel B, and then as we go on to the mono inputs from channel A or B, if it's identified as a mono input from the channel A left, then we're going to transfer channel A left to both the left speaker and the right speaker. If it's channel B right, you're going to transfer channel B right to both the left speaker and the right speaker of the personal listening device.
Okay.
So this goes a step in to kind of just show how that selection is going to be made in terms of the personal listening system once the user wants to know or wants to identify what audio source he wants to listen to.
What's the next? The top block?
The top block says receive control line input.
Receive control line. Okay. Okay, from the user.
Yes.
Okay. All right.
Next slide.
Good explanation. Yeah. All right.
So our test document, this highlights our document that we're going to be using for testing purposes. And so I'll kind of go through each step of this test document. The first action we'll be taking, or step 1, will be to set up 2 different analog frequencies using the analog discovery device. And those 2 tones should represent the column and row of a DTMF of the digit that we're trying to press. What we should expect from that is to be able to have 2 different recognizable tones being played that are different from one another. Once we go into that, we will connect the 2 individual waveforms to the inputs of a Y adapter or the beginning of a mixer. So for this example, we use a Y adapter showing the flowing from the 2 out to the 1. And so when I refer to the Y adapter, that's how I'll be referring to it right here. And so those 2 individual frequencies will be going into the inputs of the 2 Y adapters to then be merged to the outside, to the output of that Y adapter. And the analog discovery will be used to generate those waveforms to send those 2 frequencies through the mixer circuit.
Where do you have all that about the connection of the Y adapter?
That's under the Y adapter. So number 2, it says connect the 2 waveform output pins to each of the individual inputs of the pre-made Y adapter circuit.
Okay. So there you're just giving instructions on how to set up
Yes.
the circuit.
Yes.
Okay.
How to set up the test.
The test. All right. So really, that should have been. You see where it says setup. Setup is referring to that row where you have right above actions and steps. You got setup. So that's referring to what's next to it. You have systems should integrate both audio. See what I'm saying? That should be set. All right, you see?
Yeah, I see what you're saying.
Yeah, that's it. Okay. I see what you're saying. So you put your setup and your actions as part of your actions.
Yes. So for this test plan, I kind of gave them all the information they need to execute the test. So for future reference, I'll put that.
Yeah, and that still would have. Yeah, it would have been a setup. Okay, we'll talk about that.
Okay. So going down to step 3, we're going to be identifying the 2 frequencies as distinct and different from one, as 2 different distinct waveforms, and we'll be using the channels on our oscilloscopes to read the waveforms that are being generated to ensure that those 2 inputs going into the Y adapter are in fact distinct. Then once we have successfully done that step, we will connect the input pin of the speaker device to the output of the Y adapter or the mixer circuit. The speaker should play the mixed signal representation of the 2 individual distinct frequencies being generated from the waveform, from the analog discovery. Then we will use the DTMF decoder application on the iPhone to ensure that the output of the speaker and the mix is actually correct. And so, if we were to use something else like a sound and a beat and put them together, there's no way to ensure that it's actually being done correctly. So by using the DTMF decoder, we know that the way it works is it takes two distinct frequencies, and when they're both being played, it plays a digit. So we told those two frequencies that would correspond to a certain digit being pressed, and so we will know that they've successfully been merged by when we play both of them and they have been mixed through the output of the Y adapter into the speaker. The application on the cell phone should be able to hear through its microphone the DTM, the frequency being played, the combined frequency, and if it's successfully been done, the desired digit should be played. And so that's how we would know if the test actually worked. And this is testing the mixer aspect of our circuit.
All right. So basically what I'm saying is I think most of what you put in there is your actions to go into setup, and then the actual actions. You probably can actually do it as a matrix test, where you try several different frequency combinations and then look at the output. But so actually yeah, I'll talk to you about that. But yeah, I know what you're saying.
Next slide.
Oh.
So the work breakdown chart. So the work breakdown chart seems like a lot, so I'm not going to go all the way into what's going on. I'm just going over the high points. First, our pre-design. So our pre-design phase, we're planning to do some system specifications, identify and purchase some components, and then do a pre-test of our system. So within this, some of our deliverables are get a system specifications outline, document, and some block diagrams up to level 3 that will describe our system and its specifications. For identify and purchase components, we want to identify parts, place the order, and receive some of our parts to get started on our test. Set up design with components, and then run some tests. So this is going to span over like a 2-month period. Most of the team will be working on the pre-design phase as well. And the second phase is the detailed design. So we update some of our system specifications, update our documents that we created in the pre-design. We test phase 2. We rework the test setup that we did in the pre-design test, and we kind of get newer blocks tested and making sure that they're working. We also do a block integration test, which allows us to not only test those blocks independently, but start to integrate some of the blocks together and test them as they work or work with each other. And so this is going to be over a 2-month period. System implementation is our next phase. Just a system bring up, so kind of trying to bring all the parts of our system together. Once we bring all of our system parts together, we test all the blocks separately, and we combine the different aspects of the system into one unit. Market and requirement coverage, so we kind of ensure that our market and requirements are covered. Work with our advisor to make sure that it is indeed doing what we outlined it to do. And this will be span over a 3-month period to make sure that all the aspects of the system are implemented. Our overall system integration is our last phase. It should just be some product quality tests and really making sure that our system is living up to what we outlined it to be in the beginning of when we talked about it. So just test our system for quality, and this should last about a month. So, and that will be the end of our, the timeline for our entire project. So our work breakdown kind of goes over all the parts of our project in that way. And if we proceed to the next slide, we just lead into the Gantt chart, which kind of gives pretty much the same idea of what I was just speaking of, kind of over the period from starting about now, so early December 2014 to early May 2015. So this is kind of the timeline. I kind of outlined it in the last slide. So preliminary design, about 3 months. Preliminary tests, about a month and a half. The detailed design, about a month and a half. Detailed design tests, about almost 2 months. Implementation of the system, 2 months system integration and PQ tests, another 2 to 3 months, and then it should finish. So it's all going to be working in part of each other. So it's not necessarily that time frame back to back. It's some of it is going to overlap, as you can see with the Gantt chart. So that's.
I asked before, what's the blue part for? The blue part of the Gantt chart at the end.
That's more. That's actually talking about the flexible. So where you have the Gantt chart kind of showing the late start times and where there's critical path, and it's also showing that as well. So that blue portion is showing where you have a flexible time in your schedule, whereas the red is showing critical path. So things that have to be done in a certain timeline to ensure that the project is moving along schedule. Whereas the last part, nothing is essential. That is the end. So no other step is dependent on it. So there allows for more flexibility in the system. Where the other ones have things dependent on it.
You see, okay, so you go over 5 months. So that goes, the blue ends at what? Around what? 7 or 8? 7.5 months or something. So, so did it automatically, did you put some dates in it somewhere and automatically generate this?
Well, so we use the, well, more or less, yes, to answer your question, but they just kind of use a couple algorithms and a couple of basically using with the early start time because of that nature. You kind of set in the duration you wanted and the estimated start time, and then from there, based on whether or not it's.
So another thing too, I think you might be looking at the chart not in the right way. So if we look from a top down, that kind of goes through the timeline. The start is that diamond over there, and then the finish is this diamond down here. So it kind of goes over with those levels of how much time it is, what should be the time frame, which we say like 5 months to completion. And so the start date, December 1st, finish May 4th.
Where's that date at? It's in there somewhere?
At the very top.
Okay.
So that's just the time limit back in.
That's the 5 million? That's not the 5 month mark, right? Is it?
Yeah, so right here is the 5 month mark in the middle.
Right there.
And so that kind of shows that the last step we'll be working on, and that time is around there. And so based on the way we kind of set up, there's a little bit of overlap here and there, but that's just kind of based on the way we highlighted it in this framework.
Yes. I guess it's a little, probably closer to 6 months from now. So is that why it's, so 0 is now?
Yes.
Okay. So 6 months. Still looks like I'm just looking at the red part. It seems to go over 6 months. So ultimately what I'm saying is I think that needs to be made a little more clear. And maybe even have the dates somewhere on the Gantt chart itself to give you an idea of what the month is going to be, what month, all these different things. So is this like some type of tool, Gantt chart tool that y'all use?
Yes.
Okay.
It's like an online template we use that Excel provides.
Okay. I'm still not quite understanding the dot, but maybe I can explain it to you. You're not the dot, the diamond at the end. But maybe I can explain it to you later. All right. You ready to go next?
Yes. All right. So here is like pretty much our summary table of some of the parts that we know for a fact that we're going to need right now. So first we have some resistors that are going to help with our circuits. The spool of cables also going to help with the actual hardware part. We have a broadcast and receiver, and we have LEDs, which we're going to use for indicators. We have audio input and output jacks. We also are going to need some switches, or we can actually have buttons for helping with selection. And then lastly, we have analog nuts and inputs. This is just a slight overview of the price range that I've seen from switching and seeing which would be the less, which provider has the least price. So that's the provider. We have more information. We also save links so that we can also go back when it comes time to purchase these products.
So why do you have the broadcasting and receiving? combined?
When I was trying to get it separately, but when I was looking, they actually have some that come together. So I don't know if we're gonna actually use the one that we bought, or we're gonna actually open it up and put it in our circuit where we could actually separately use the abilities.
This is like the headphones, the wireless headphones? Is that what?
The broadcast
900 megahertz, is that what?
for the broadcast and receiver part.
Mm-hmm. Is that?
I want to say wireless headphones, but it looks like a
Like the 900 megahertz frequency.
Yeah.
That the same thing, but it wasn't actually the headphones itself. It was more so the receiver, the transmitter, more so the actual.
Oh, so it was like a circuit board or
It was actually a unit itself, more so enclosed.
something you can use to
Exactly.
put in your own product.
Exactly.
Design your own product. Okay.
So more so a hub than an actual endpoint.
Right. Okay. Okay. I got you. And you say one each. What does that mean? The quantity of those?
That's
How many does that translate to? One each.
You know,
So if you buy it separately, or if you try to buy two, it'd be $31 for one because it's a broadcaster or receiver. Or if you were gonna do it in the combined, like you said, you would just buy one, or you would try to work with its capabilities within it, or you would buy two to have one as a broadcaster.
So for
what I have here, it would just be the one. But that, like you said, if it was just separately, then we want each one broadcaster and receiver if we're going to buy it separately. But for the event that I said, it came together.
All right. So I think we need to reconsider that too. How many we're going to actually need? Because we want to each broadcast two stereo channels. Then we're going to figure out how many receivers we're actually going to take from there. So we don't need to define that. That's your stuff. All right.
Okay, so this part is our external student design competition. So we're supposed to be a part of the Texas Instrument Innovation Challenge, the North American Design Competition for 2014. We're designed to encourage engineering students to submit design projects that utilize TI technology. So as far as to be eligible to be a part of this project, we have to find a way to implement some TI technology in our design. So right now we're just in the preliminary stages. So
All right.
we have a
We are
test
registered
site.
for.
Yeah,
Yeah,
for
for
sure.
sure. I got the emails and stuff. So. Okay. Have you identified any parts that might be reviewed?
Not at this current stage.
When you look for parts, when you look for like the receiver, broadcast and receiver. So which parts do we think most likely might be? That might be made by Texas. I don't think maybe the broadcaster receiver might be able to find it. I don't know. Analog mux, they make some analog chips. So we may be able to find something.
I think why we haven't highlighted the TI things, I think we were trying to go with more cost efficient at this time. So we weren't really searching specific TI, but there may be some TI devices that are, like you said, analog mux or broadcasters.
Yeah. Okay. So what's the requirement? How many Texas Instrument parts is one required?
Specified.
I don't remember exactly how much it is, but I know we have. I think you have to implement either one or two.
Somebody's having two. Yeah, we'll get clearer on that. All right.
So in conclusion, we just want to go back over some of the things that we discussed. The background and problem analysis, our need and objective statements, our requirement specifications that help guideline, how we're going to process through developing our system, our level 0 through level 2 block diagram that show our preliminary designs, UML diagram that goes through some of the thought processes of how we plan to make block work, test document that shows our tests for the preliminary design or our demo, work breakdown chart goes over who's doing what and what is everybody's input. The Gantt chart goes over the timeline of the project, Cost summary table gives in just kind of some of the preliminary things that we consider to purchase for our project, and then external design competition that we're considering or being a part of and actually partaking in. So that's the end of our presentation. Next slide. Any questions?
Okay. Let's say out of all of this, let's say what's your let me change that question. What do you see as your next step?
Next step. The next step is to make sure our preliminary design phase is complete. So kind of just making sure that we at least have a quality test for one of our blocks, and so that we can move forward to really understanding another block and outlining a quality test for that block for the design phase. So for the detailed design phase. So yeah, the next quality next step would be just ensuring that our preliminary design phase is fully tested and allows us to make further progress towards the detailed design phase.
Okay. All right. When you say preliminary design, you mean what's the demo going to be?
Yes.
All right. But I'm saying after this point, let's say the beginning of the next semester, what's going to be the first, or even over the break from that, what's going to be the first thing we're going to look at?
I think we're going to look at one of our other blocks, since we kind of understood within the audio selection unit, we kind of understand the channel, the stereo mono mixer. We're going to try to make sure that we get a good logic understanding of the channel system to ensure that we can actually finish the audio selection unit and move on to another block on level 1.
What do you foresee as being most challenging?
Right now, the most challenging might be really understanding how to get the audio selected at the PLS phase. So really figuring out that that interaction, even though we went over the UML diagram, really understanding the inner workings of how to make that selection process based on the 6 different possibilities. I think that might be a little more challenging.
I agree. All right. All right. Good job, y'all.